Hello everyone, let's try to be a cheat code ninja today. This problem covers an important topic, bipartite graph, and the approach discussed over here can be very handy in solving different problems. Let's look at it. We are given n people labeled from 1 to n, and we have to split them into two groups. It is given that some of them dislike each other and they should not fall in the same group. And we have to check if it is possible to split them into two groups. In the first example, we have to split 4 people into two groups. Person 1 doesn't like person 2, so they have to be placed in different groups. Person 1 doesn't like person 3, so they have to be placed in different groups. Since person 1 is already in group 1, person 3 has to go to group 2. Similarly, person 2 and person 4 have to be in different groups. Person 2 is already in group 2, so person 4 has to go to group 1. So it is possible to split 4 people into two groups. The second example, we have to split 3 people into two groups. Person 1 and person 2 have to belong to different groups. Person 1 and person 3 have to be in different groups. So person 3 will go into group 2. But person 2 and person 3 have to be in different groups. But as you can see, they are already a part of the same group. Hence, there is a contradiction. Let's try to come up with an intuitive solution for this. Let's try to understand this problem with the help of this example. Initially, the first person can go into any of these two groups, but all the other people who are disliked by person 1 or they dislike person 1 have to go to the other group. So let's add person 1 into group 1 represented by green color, and let's add person 2, 4 and 6 into group 2 represented by the red color. Now we are done with person 1. Let's try to repeat this process for person 2. We see that person 2 is already assigned color red. When we look at this pair, person 2 and person 1, they have to be in different groups. We see that person 1 is green, so there is no contradiction. Person 3 has to belong to a different group than person 2, so we'll assign it color green. Similarly, person 5 has to belong to a different group, so we'll assign it color green. Now we are done with person 2. Let's repeat this process for person 3. Person 3 and person 2 have to belong to two different groups. Person 3 is already green and person 2 is already red, so there is no contradiction. Now we'll do the same thing for person 4. Person 4 and person 1 have to belong to different groups, which is indeed the case, so there is no contradiction. Similarly, person 5 and person 2 have to belong to different groups, which is indeed the case. And finally, person 6 and person 1 have to belong to different groups, which is indeed the case. So we were able to divide these people into two groups without any contradictions. Let's see what happens when we add another pair of dislikes entry. So according to this, person 2 and person 6 have to belong to different groups. But we see that person 2 and person 6 are already placed in the same group. Hence there is a contradiction. So we cannot divide these people into two groups. In this approach, what we are actually doing is for each person, we are going through all the disliked persons and placing them in different groups. So for each person, if we can somehow connect all the disliked persons in a graph, we can do a depth first search traversal to find any contradictions. For example, we'll start with person 1. Initially, we'll mark him with green color. And for all the connected disliked people in the graph, we'll label them with color 2. And when we are done with color 1, we can choose its first neighbor. We see that it is already assigned color red, so all the people connected to it should be assigned color green. Person 1 is already colored green. We'll mark person 5 with color green. Person 6 should also be marked as color green, but we see that it is already marked as color red, so there is a contradiction. One final thing to consider is that we can have disconnected components in our graph. For example, person 1 and person 2 can be placed in two different groups. This will form our first connected component because it does not connect to person 3, 4 or 5. And similarly, when we look at these two dislike entries, they form a connected component. So we have to make sure that we do not find any contradiction in any of the connected components. We can assign person 3 to any mark it with color green and person 4 with color red. Person 4 is already marked as color red, so we'll mark person 5 as color green. So there are no contradictions in any of these two components. The time complexity will be, we'll have to go through all the edges of our graph once. And for each person, we have to make sure that the connected component they fall into has no contradiction. So it will be O of E plus V. And our space complexity will be, we have to form an adjacency matrix that will take O of E space, and we have to assign each person a color that will take O of V space. This will be in heap memory, and we also have to call depth first search for each person, which will take O of V stack memory. Let's implement our solution. Let's define a hash map with list as its value to store our graph. We'll now go through each pair of disliked people, and since we have to place them in different groups, the relationship will be bidirectional. So we'll store 2 entries in our hash map corresponding to each person. We'll use a hash map to store the color of each person. We have to check for each person if the connected component they fall into has no contradictions. So if that person is not part of any previous component that we have seen, he will be uncolored. We can assign that person color 1 and call depth first search on that person to find any contradiction. If we find any contradiction, then we can return false immediately. And after going through all the components, we did not find any contradiction, then we can return true. Now let's write our DFS function. Our DFS function will take that person and a color as an input parameter. We'll assign that person with that color. Now we'll go through all the disliked persons or the enemies of that person. We'll check if that enemy already has a color assigned, and if that color is equal to the color of our current person, that means we have a contradiction. So we can return false. Now we'll go through the case when that enemy doesn't have a color assigned. In that case, we'll assign him a color which is different from our current person. We can use this formula. 1 minus our current color will give us the inverted color. This works for both the colors 0 and 1. And after that, we can call DFS on that enemy and try to find a contradiction. If we find a contradiction, then we can return false. And after going through all the enemies, we still didn't find any contradiction, then in that case, we can return true. We are done with our solution. Let's submit it. As you can see, our solution is accepted. If you have any doubts or concerns regarding this solution, please mention in the comments. If you thought this video was helpful, please leave a like and subscribe to the channel for more such content. Thanks for watching.